This demonstration is an introduction to arrays. Uh, Before you do this, I'm going to assume that you have read the book and looked at the lecture notes so that you have some familiarity with what arrays are and the terminology that's associated with them, as well as what's happening in memory behind the scenes. I'll review a little bit of that, but if you haven't done that yet, go back and do that first. All right, so and arrays are a really nice way to manage groups of like data. So for example, maybe we've got 35 students in the class, and so we want to store their names, 35 names, and we want to store their test scores for test 1, 2, and 3. So 35 test score 1, 35 of test score 2, 35 of test score 3. If we've rather than creating multiple variable names, we can use what's called an array. It's a two-part name. And so what that does is an array is an area of contiguous. That means next to each other, consecutively located and sequentially numbered memory addresses. All right. It's important to note that we use a subscript, often called an index. Those terms are used interchangeably. And we start counting at 0. All right, so if I have 3 values, I start counting at 0. So my index will be 0, 1, and 2. Let's do this for some simple numbers. Suppose um, I want to store 3 values, but they're all related. It's test 1. I, you, I have a two-part name. So test 1 is the identifier, the name of the array, and I use square brackets, and I tell them, and I have to identify how many how many tests I'm going to um, have in my group. All right. So now if I want to assign a value, I have to use my two-part name. And I start counting at 0. That's the initial memory address location. And now I can do test 1, the second value, right? Well, the second value has a subscript of 2. And the third one has a subscript of 2. So you're off by 1, and that's something that you're going to have to keep track of as you're programming. We start counting at 0, and then we're offset by 1 or 2. So this identifies the beginning memory address location where I can store a value. I move to the next memory address location. I'm off by 1, and then I store this one and this one. So I can input manually like this. For loops are really useful when you're using arrays because you know the size of your array. In fact, we must declare a constant for the size of the array. It's a limitation. It's how arrays work, and that's because your compiler needs to know how much memory to reserve when you start your code. We're going to learn a little bit later. Vectors have a little more flexibility, but with arrays, we need to have a constant. So if I wanted to do a for loop, if I want to output this, I'm going to call it index, and I'm going to start my index at 0, not at 1. And as long as index is less than size, not less than or equal to, then I'm going to increment. Oops. Okay, and all I want to do is output. And so what's nice about this is I use my index as my subscript, test 1 actually. All right. All right, so I have 3 students, and I'm going to store test scores for 3 students. In order to assign values, I need my two-part name, my array identifier, and my subscript that goes in square brackets. Let's run this and see if this works. There we go. So we read it into the array and we output it. That's just confirmation that we did it correctly. Um, Now I want to show you a couple of variations on this. I can manually input the values. So I want you to see that you can access um, test sub uh, test 1 sub 0, test 1 sub 1, and test 1 sub 2 is often the terminology that we use. Or I can initialize it using my assignment statement, curly braces, and commas to separate the elements. I can say 98, 87, 77, and end with the curly braces. All right, let me comment this out. This will have the exact same effect. Rather than assigning one at a time, I initialize it at the beginning, and now let's output it, make sure it works. And there we go. That works just great. Now I want to talk about, this is initializing it. Okay, I can initialize it when I declare it. I can also do this. There's something called a partial initialization. If I change the size to 5 and I initialize 3 values, it will automatically set the remaining values to 0. So it's kind of a quick way to initialize if you don't know what all the values are, but you want them to be 0. This will do it for you. So 3 values and 2 zeros were tacked on the end. Okay, this might be even more useful if you just want to initialize it. That will initialize every element in the array to 0. Quick way to initialize to 0. And now all 5 are set to 0. Let me just show you one of the nice things about arrays is it's so easy to expand it. Suppose I've got 50 values, and just for kicks, let's set it equal to 55. We're going to initialize every element in that array to 55. I'll build it and run it. Yep. I lied. That only initialized the first one to 0. So let's go back. I was trying to get too fancy there. So if I want to initialize all 50 to 0, let's do that. There we go. Okay, so I can easily scale my array by changing the size. I can initialize manually or using the curly braces. Um, I can also use my uh, for loop. I can read data in from an input file, which we will do a little bit later. So right now we initialize it to 0, but if I set this up correctly, I can open an input file, I can read the data from an input file and then store it in my array so I can use it for processing. Okay, there is one other issue I want to make sure you're aware of. There's a very common error. It's called the out of bounds error. Array out of bounds. Beware. This happens frequently, especially when you're starting to work with arrays. And it happens because we have to remember we're starting at index 0 and we have to check for less than size. If we say less than or equal to, it's going to try to move one element out of bounds of my array, right? I only have room for 5 ints, and that's index 0, 1, 2, 3, and 4. If I try to move to index 5, it throws an error at us. We're out in space. It doesn't have that memory reserved, and it gives us an error. So I want you to experience that error because you will probably see this, and you will have to recover from it. All right. So I tried to display what is stored in test 1 sub 5 but there's nothing there. There's garbage there. All right. In some versions of a compiler, you might get a runtime error. In this version, there was some garbage in that memory location that was contiguous, consecutively located next to it, so it showed the garbage that was sitting there. All right. You can use this same approach for other types of arrays. Suppose I want to input names. Okay, I will declare name, and now I'm going to ask the user to input the name. Actually, let's just modify this. Let's take this equals out. We don't want that out of bounds error to occur. That's no good. Let's take this out. We're going to ask the user to input a name and a test score. Okay, now notice I'm prompting the user to input a name for a student, but I don't want to say student 0. So to keep it user-friendly, I add 1 to it. So internally, we start counting at 0, but humans start counting at 1. So input a name for student 1, and then I want to use getLine. I'm getting it from the keyboard right now, and I'm going to input it into name subindex. Right? It's the index that's going to rotate between 0, 1, 2, 3, and 4. And then I'll do something similar. And we'll input the score. Okay, this is a way to use a for loop to get input. And now I'm going to verify that I read it into the array and use a for loop for output. So I'm going to use a similar setup here. This is what's so nice is my for loop looks very similar. I'm simply going to change. Oh, let's do this. We don't need a string. We'll keep it simple. Oops, equals test1 and index. All right. I'm going to do a couple of end lines here just to keep it a little bit cleaner. So here's my input, a couple of blank lines, and then here's my output. And so I want you to notice that the for loop structure is the same because the array is the same size. And this is using what's called parallel arrays, name subindex and test1 subindex. So index sub 0 is for the first student and the score for the first student. Let me clean this up a little. And let's run that. Okay, so we got Ruth Bader Ginsburg. Oh, and I forgot to not initialize. So let's fix this. My mistake. I don't want to initialize it here. I want to input it from the keyboard. Okay, so only thing I'm initializing is size. Okay. Well, input the score for test 1. It didn't like that at all, did it? So you know what happened? I ran into this issue with getLine and CN. So what do we know we have to do? And so I have another error here. I don't know what I was thinking. I was trying to do a C out here, and what I want to do is a C in. All right, I want to use getLine, and I want to use C in. And then I'm probably going to want to use cn.ignore because I've got getLine and cn used in a looping structure. But let's see the error first, and then we'll fix it. And then for student 2, it skipped ahead because we have to use cn.ignore. So in between a cn and a getLine, I need that to eat up that end of line character. Student name. Oops. Okay, so here's all my input. My for loop went around 5 times. Index was 0 through 4, but the student number was 1 through 5. And then we output the information. This just confirms that it was stored correctly. All right, that is a brief introduction to arrays using a simple one-dimensional array for integers, a one-dimensional array for string, and this is what's called a parallel array, meaning that the indexes are related. So index 0 applies to test 1's sub 0 as well. This is going to be very useful as we continue with our work with arrays.